Kia ora Year 12 and Year 11. This is an AS Stats question. It's a request from George, and it's mainly a normal distribution question until we get to the last bit, okay, where it's something a little bit different. It's quite a nice question. It's really good practice for basic standardizing and inverse normal problems. So it's a pretty silly context. We're told that the time it takes to cook an egg by people living in a certain town has a normal distribution with a mean of 4.2 minutes and a standard deviation of 0.6 minutes. So first we have to find the probability that someone chosen at random takes between 3.5 and 4 minutes to cook an egg. And then we're told that 12% of people take more than this many minutes to cook an egg, and we have to find what that number is. And then I'll come back to part 3 soon. So let's do the first part first. So pause the video and have a go at it on your own. This is what my working looks like. So I start by saying X is normally distributed with a mean of 4.2 and a variance of 0.6 squared. And we want to find the probability that X is between 3.5 and 4.5. The first step is to standardize that and to turn that into two Z variables. So when we standardize, we subtract the mean and we divide by the standard deviation. And I do the same thing to the side. So we've got 4.5 minus 4.2 over 0.6. And we're going to clean those numbers up and not round them too hard. So we get negative 1.6. Now what did I do here? I did negative 1.1667, which is slightly more decimal places than my table is going to do, but that's okay. Now the next thing, of course, I'm going to tell you to do is to draw a picture. And the picture is a Z picture. Let's turn off the weird shape thing. Let's try that again. So here's my curve, and I'm looking for the area. This is Z, and this is 0.5, and this is negative 1.167, which I think is what I ended up using in the table. So this probability can be found like this. It's going to be the area below 0.5 minus the little bit of area here below negative 1.167. So that equals phi of 0.5 minus this area here will be 1 minus phi of 1.167. Right, so now we can go to the table and we can check what those numbers are. So for 0.5, it's easy, it's a nice value right here. And for 1.167, it's 1.16, and then I need to add on these digits over here. So that gives me 0.8770 plus those 14 extra points, so I get 0.8784. So now we can go back to the problem and we can say, well, we want 6915 minus 1 minus 0.8784, and when you chuck that into your calculator, you get 0. What was my answer? 0.570 to 3SF. So that's the first bit done. Now the next bit is a standard backwards question. We have to find the time such that 12% of people take more than that time to cook an egg. So again, we're going to start by drawing a picture. And I start off by drawing my Z picture and saying, I don't know this value here that's going to cut off 12% in that tail. But I know that if there's 12% in that tail, there must be 88% here. So what I'm doing is I'm looking for the Z value that will give me the area of 0.88. So I go to my tables again and I hunt through for 0.88, and I can see, where is it? It's quite close to where we were. So here's 0.8 sitting somewhere around here. So it's going to be 1.17 with an add-on of 5 points. So it's 1.175. So little z is 1.175. Little z because it's a specific value of my standard normal distribution. But now what I want to do is to work that back to my x distribution. So I'm taking this number here and transferring it over here, and that's going to be t. So z is equal to x minus mu over sigma. We substitute in what we've got 1.175 is equal to t, the value we don't know, minus 4.2 over 0.6. So t works out to be 1.175 times 0.6 plus 4.2, which gives us 4.91 minutes. Now, I should have said early on that we've got minutes, but we haven't rounded anything in here. So I'm not doing any kind of continuity correction. Usually in AS questions, you're going to need to do a continuity correction when it's screaming at you that the data has been rounded to the nearest minute. But you're always going to have to do one when you're doing a binomial question and you're just using a normal to approximate it. But in here, there's no need for a continuity correction, and it would be the wrong thing to do. Okay, so the value of t is 4.91. Right, this last one looks hard, but it's not if you think about a tree diagram. We've got a random sample of n people. We have to find the smallest possible value of n, in other words, how many people in the sample, if the probability that no one takes more than t minutes to cook an egg is really, really low. Now, even if you mucked up the last part of the question, you can do this pretty easily if you draw a picture like this. So we know that 12% of people take more than t minutes to cook their egg. So let's think about what a tree diagram is going to look like. Here's my first person. I'm just going to put more or not more. So 12% of people take more than 12 minutes, take more than t minutes, and 88% don't. So that's the first person. We want to know how many people will give us the probability that no one takes more than t minutes to cook an egg. So what we've got is we've got this tree, and we want to be following down the not more branch every time until we've got to our last person. So what we can say is this, that the probability that none take more than t is going to equal 0.88 to the power of n. And now we have to solve 0.88 to the power of n is below 0.003. We take logs of both sides. And now we're going to divide both sides through by this. And that's a negative number, so we have to reverse the inequality. Now, n here works out to be 45.4. This is one where we definitely don't want to round down. So the minimum number of people we need will be 46. So there you go. So George, hopefully that helped. As is often the case, the answer to the hard part of the question is actually using a really simple idea from somewhere else in the course. So in this case, it was spotting that it was a probability tree and that we could just work down that one branch there.